CFD, or computer fluid dynamics, is actually one of the most compute-intensive kind of simulation. And that's the sort of simulation that can test even the limits of the most powerful workstations. Today, we're going to hear how you can overcome some of these challenges and issues using an on-demand, specifically Cadence on Cloud solution. After that, we'll take your questions.
The graphic below shows a high-level overview of the HPC architecture on OnCloud. From the left, on the left, you can see engineers securely connect to the OnCloud platform through their browser, through HTTPS, or upload design data through SSH. OnCloud has a layered security protection, and we use industry security frameworks, standards, processes to manage its security and risks. For a cloud-based workflow, visualization is key. For best graphics performance, OnCloud leverages the AWS AppStream service with GPU-accelerated visualization to provide best user experience with practically the same look and feel as a local workstation. And connected to this visualization node is an auto-scaling HPC cluster with built-in job scheduling. That means when submitting a job, the scheduler will allocate and provide the required resources, run the job, and when completed, deallocate the compute nodes, fully automated, for a most cost-effective use of the resources.
We go now on the geometry preparation. You have a flow coming through the inlet, the red one, and then it will circulate inside the volute and will go out from the outlet, the orange plane there. We are now preparing the domain. The domain is where the flow will go. You see the seed point here, and the seed point is well located inside the domain, so we have a good domain to start the meshing part. So we go to next step, which is the meshing part. We have prepared two meshes. One is the coarse mesh, and the other one is a higher density mesh, the simulation one. If you see simulation one, now it's finished, then we see the convergence of the simulation one. We'll check as well, you see the convergence of residual. We'll check the physical quantities. I think this will be, yeah, we will check the mass flow at the inlet and outlet and comparing both, and you see that these converge. It means that our computations converge well. That's really, really good. Then from here, we can start then analyzing our results. We can go to the next step, the result analysis, and we can choose any variables. Now we would like to show you what happened inside. So we cut the volute and see what happened inside. We choose static pressure, and what you see here is the value of the static pressure inside the volute. You can then post-process many variables that allow you to design well your machine.
What kind of internet connection is required to do this effectively on cloud? So, Alex, do you want to take this?
Yeah, maybe I can take this. Yeah, it sounds like a pretty simple question, but when you think about the requirements that engineers have with their on-premise workstations, that's actually a question like thinking about migrating all these workflows to cloud. That's a question we actually get quite often. But as I said, with OnCloud, we are leveraging AWS AppStream service. So that's the GPU acceleration is basically done on resources in the cloud, and the image is actually just streamed through the web browser. It's a bit similar like watching movies these days. You can actually do a lot and get very high quality. AppStream uses nice DCV technology. It's bandwidth adaptive protocol. So that means even with like working in home office, or even when you are traveling with a 4G internet connection through your mobile phone, you get a very good resolution, real-time responsiveness. So it basically really works great without special requirement of the internet connection.
All right, very good. Here's another question. Can I run jobs concurrently? If so, how many can I run simultaneously, concurrently? Aji, do you want to take this?
Yep, I'll take this one. Yeah, as you have seen from Alex's presentation, you see Finocon run 59 jobs concurrently. I think there is no limit. This is high performance computing. You can then run any job as you want. Of course, when I say no limit, you may go into something more, 100, 200, 300. But if you really go far from that, then you need to warn us, and then we will prepare for that. But this is no limit. The limitation today is that per job, so you are limited to 720 cores. But I think there is very, very small number of job run on 720 now, and we start to have solver using GPU that will replace this high number of CPUs as well.